Hi everyone, welcome to the class. In today's class, we'll be discussing the complexity of the adjacency list. So in the last class, we saw how we can represent the adjacency list. Okay, so consider this graph, and this is the code that we wrote in the last class for the adjacency list. Now, you want to find whether a node, say 3, has an edge to node 4. Okay, so basically what we want to do is we want to check whether there is an edge from node 3 to node 4. Now the way we do that in the adjacency list is we iterate over all the edges in the adjacency list corresponding to that node. So for our example, we will go inside the adjacency list 2 and we'll iterate over all the edges, and in one of the edge we'll find that there is an edge from node 3 to node 4. So coming back to our code, so there is an edge from node 2 to 3. So now what would the time complexity? We will be traversing each and every value corresponding to adjacency list of that particular node. So the complexity will be maximum number of edges which can be there in that particular node. So it comes out to be order of n, where n is the number of nodes, number of total edges. And what will be the space complexity? So we need, say n is the edges and m is the node. So we will be storing m. So we'll have an adjacency list of m nodes of size m, and and each one of them will store some edges. So total complexity will be O n plus m. Now let's consider the complexity of adjacency matrix. If we want to check if there is an edge between node 3 to node 4, we can just look up in the matrix. If it comes out to be 1, that means edge is there, otherwise no edge. So the lookup, since it's an array, it's a 2D array, lookup will happen in O of 1. So time complexity to check whether there exists an edge between two nodes is O1, and space complexity, since we are storing, since it's an 2D matrix of n cross n nodes. So space complexity comes out to be n square. So that's the space complexity where n is total number of nodes. Okay guys, yeah.